before. And for those who are coming for the first time, welcome to this live. This is an AimHi live, so you can ask questions whenever you want. And so the topic today is, why does Coca-Cola erupt with mentos? But it may go in other directions as well. So just throw questions into the chat. If you're here already, like say hi in the chat. Let me know that you're here, and we'll get started in a moment. Before we get properly started, though, on the topic of why does Coca-Cola erupt with mentos, what do people think this is? What are these? But first, what are these? And yeah, I'll see what people think about that while we're getting going. Yes, if you're arriving late, then as I just said, this is an AimHi live, so throw questions into the chat. You can steer this in whichever direction you want it to go in, and we will cut. We're gonna do why does Coca-Cola erupt with mentos, but we're gonna do quite a lot of story around that, and we're gonna start with this. What are these things here? What's that? Okay, gonna give it just like a few 30 more seconds or so before we get going, but waiting to find out what people think this is here. What do people think these are? Any ideas? Stratus clouds. Roz is first in. Okay, so Roz thinks they might be stratus clouds. They are a very strange kind of cloud, which is kind of like grapes. And they only form under quite weird conditions, and they're called mammatus clouds. Apparently I missed heaps of chat because my chat was just reloading, so apparently everyone's been talking to me and I just haven't seen any of it. I just thought no one had said anything, so thanks for saying some stuff. Right, everyone's saying hi, shout out for the Hellerman, hi Jeff, hi Mia Dunn. Okay, someone says mento clouds. Yes, that's such a better idea than mammatus clouds. And then Ross just said stratus clouds. Right, yes, so cracking on. They're called mammatus clouds. That's almost definitely not how you spell mammatus. I'm pretty sure it's got another M in the middle, but I can't spell, and that's just how it is, I'm afraid. Anyway, I wanted to, like, a lot of this is going to be about clouds, as well as being about mentos, and Coke, and a lot of it is also going to be about this. So here's a glass. Wait, let me just switch to full screen for this. Here's a glass, empty, as you can see. Now, I'm just gonna fill this with some water. Delicious water to drink. I hope everyone else is hydrated. Please keep drinking continuously without stopping during this to maintain maximal levels of hydration throughout. Right, okay, so here's some fizzy water. What do you guys think happens if I drop a raisin in it? Hey, what's going to happen? Let me know what you think in the chat. And I'll just wait here, I suppose. So Japan Maple thinks it'll float. Jeff thinks nothing. Miadoan thinks fizzy water tastes static. Yeah, fizzy water's rubbish, isn't it? I'm so not big on fizzy water. So I know I said it was delicious, but actually, really, I was thinking this tastes rubbish. Fizzy water, it tastes like a static TV. Wait. It does taste like TV static. Yeah, right. Okay, so Roz thinks it fizzes. Okay, I'm going to show you. Drop in a few actually. Oh. Give it time. Got to stay really still. That's so cool, right? Why do you guys think this happens? Yeah, it's like yeah, Japan Maple thinks it's like a lava lamp. Wait, Mia, Mia, are you saying boring or boring? Because I think you typed out boring. Maybe the races are boring. I hope they're not boring. I think the races are really cool. Anyway, so what's happening is the bubbles are What's happening is that I'm a wizard. Thanks, Pumpkin Master. And also, apart from being a wizard, the raisins are collecting bubbles at the bottom, and then the bubbles are carrying them to the top, and then they drop the bubbles off at the top and then sink back down again. And we're going to talk about that as well. And I'll come back to this in a mo. Thanks for not saying it wasn't boring, Mia. No, it was an accident. Okay, right. So going back to this. So these are mantis clouds. Now, one of the big question that I want to kind of center this around is this. We've actually talked like in multiple of these lives about the temperature that water should turn into a liquid. So if you've got water in the sky, so if this is a load of water vapor, what temperature does water normally go from being a gas to being a liquid? What temperature does that normally happen at? What do people think? And just to let people know, if you're just joining us live, if you're just joining us late now, this is an AimHi live, so you can ask questions whenever you want. It's interactive, and I'll steer it based on what people say. We've just been looking at these raisins moving up and down inside this magic glass, and now we're talking about clouds. Okay, so people are saying 100 degrees C is when water normally goes from a gas to a liquid. Is normally at 100 degrees C. So obviously water goes into the sky when it turns into a gas, and then it falls out of the sky as a liquid, right? So if this normally happens at around 100 degrees C, why is it that all the gaseous liquid in the sky is not falling out the sky? Because is the sky 100 degrees C? Doesn't seem right? So do people have any ideas why the water might not turn into a liquid and then fall out of the sky? Why might it stay separated in a gas-like form? Jeff's saying nice to have no. Okay, Jeff's suggesting maybe evaporation. So evaporation is how the water gets up there in the first place, but still there's something strange going on. There's something that is stopping the gas from turning into a liquid up here in the sky, because we know that it should be, and people are talking about low air. Mia Doan's talking about low air pressure, which is brilliant, exactly. So there is the low air pressure, which is also contributing to holding it further apart. But still, even with that taken into account, which is important, you would think that how cold it is up in the clouds, you would think that it would still be turning into a liquid and falling out of the sky. But there's something else that's stopping these particles of water coming together and forming droplets of water. There's something else going on that prevents that happening to form the raindrops. Quick question. What shape is a raindrop? What shape is a raindrop? What shape is a raindrop? What do people reckon? And wait, I'm just going to catch up on some of the comments. People think that it not raining, even though it's cold up there, is an active rebellion against physics. Yes, you're right, Miz. There's quite a lot of tension between the water in the sky and physics. It's quite political, and I don't really want to go into it because it's quite a stressful topic. And Pumpkin Master is saying there are other gases up there. It's true there are other gases up there, but still, you would think that the water would come together and form these droplets. Roz is saying, does the boiling point of water increase as it gets higher? And actually it decreases as it gets higher, because higher up in the sky there's less pressure, because there's less air piled above you when you're higher up above, because you're closer to space. So There's less air above you, less weight on top of you, less of this pressure. So all the particles are more easily pulled apart. All the particles get pulled apart, and so actually things evaporate way more easily higher up. And then what did Mia say? So as it's a liquid, it doesn't have a specific shape. And Japan Maple is saying circle at the bottom with a point above. Depends if it's falling or not, is what Mia Doan says. And Roxy says raindrop shape. Mia Doan says word. Right, so raindrop shape is that kind of shape, right? And that is the shape that people always think or often think rain takes. But actually, rain falls in perfect spheres. They're perfect spheres. Absolutely perfect, because when the rain is going, when it's falling at a constant speed, because it gets up to a certain speed and then it can't go any faster. And at that constant speed, all the forces are balanced. Because we'll do this another time, but like one of the really important things about movement is that you only feel a force when you're changing speed, right? Like think about being in a car. You only feel the force when you're accelerating or slowing down, but when you're just going at a constant speed, you don't feel anything. And it's the same with a raindrop. When it's falling at a constant speed, it feels nothing, and it's just a perfect sphere. Now, you might see, if you go browsing around the internet, you might see some people do this amazing kind of photography where they use falling raindrops as mini fisheye lenses. So they'll set up their camera so it's perfectly focused through a raindrop as it's falling, and then you'll get a picture through the raindrop that'll be like a whoosh, like an expansive picture of the surroundings. I'm sure I have one of those pictures. I'll show you that next time, because it's so cool. Let me just write that down. Anyway, right, so yes, there's something going on that is stopping these small particles of liquid from coming together. I'm just going to catch up on some comments. Roxy's right, yeah, the raindrops fall at terminal velocity. And Mia asks, does that mean there is no such thing as a snowflake? There is such a thing as a snowflake. And if a fly is flying around in a car going 60 miles per hour, is it flying 60 miles per hour too? Well, the fly won't feel like it's... If you've got... So I'm just going to answer Japan Maple's question. If you've got a car and inside the car you've got a fly and the fly is flying along and the fly is just stationary inside the car, if the car's going at 60 miles per hour, then the fly, will be going 60 miles per hour if you're like stood outside the car and you're looking at the fly only and you're like, whoa, that fly went past quickly. But as far as the fly can feel, it's going at no speed at all because it's just moving with the car. So yes, doesn't the continuous airflow deform the raindrop? And the answer is no. As far as I know, the forces all end up balanced, and so it does end up as a nice sphere. Do check that out on the internet. There might be some small amounts of deformity because air is not completely uniform all the way down, and some bits of air are thicker than others. You know how you get turbulence in an aeroplane, so you might have some distortions in the shape, but pretty much perfect sphere. Jeff's just asked a question as well. What if you fire a bullet off a car? So if you have a gun on top of a car and it fires at 300 miles per hour, if the car is also going 60 miles per hour forwards, then the total speed that the bullet will fire at relative to the ground is 360 miles per hour. So yeah, they just add like that. And if the car was going backwards, then what speed would the bullet go? What do people think? $240 miles per hour, exactly. Yeah, you just minus it off. And that's true. That's true with anything like that, except for light. Light is the only thing that doesn't work for. So if you're firing a beam of light, no matter the speed of the thing firing the beam of light, it will always arrive at the speed of light, regardless. And to do that, it distorts time, and that is super cool. And we will talk about that another time. Whole relativity. Okay, cool. So we're going to go back to talking about why these small droplets don't want to come together. Why is it that these small particles of gas don't want to join together to make these raindrops? So, Mentos and Coke. Who, Who here has not yet done this in life? Taken a bottle of Coke and put a load of Mentos in? Who here has not done this yet in life? Because if you have, you've got to do it. Japan Maple's done it many times, an experienced Mento Coke combiner. Yeah, it's cool. So, if you, obviously, you know, people know that if you put together Mentos and Coke, then you get this huge explosion. Now, a really important thing, this is not a chemical reaction. There's no chemicals reacting, there's no chemical change. None. This is not a chemical reaction. This is an entirely physical reaction. And how it works is this. So the Coke is kind of like, is full of dissolved gas. Does anyone know what the gas is that's dissolved in the Coke? It's full of it. And it's the same gas that's dissolved in here as well, that you can see fizzing when you shake it. Yeah, exactly. Carbon dioxide, Japan Maple, Pumpkin Master, Jeff, all coming in with the right answer. Yeah, so it's full of dissolved dissolved carbon dioxide. Now, the carbon dioxide doesn't want to be dissolved in there, right? It doesn't want to be dissolved in there, and yet it is. So the question is, why does the carbon dioxide all not just come out immediately? Why does it take its time over it? What's slowing it down? Like, it doesn't want to be in there, but and yet it comes out very, very slowly if you just leave the Coke standing. Why do people think that might be? And yeah, just one last time, if you're joining us late, this is an AimHi Live, so get a Twitch account if you can, and then you can interact live in the stream, and you can throw questions in, and I'll respond to like most of the stuff that's coming in, so you can get involved in steering the way that this will go, like how we just did with a bee inside a car. And Japan Maple said it had to latch on to like dust or something. Okay, right, yes. So there's a similar thing going on where the small little particles of CO2 are really struggling to come together to form bubbles that they can then go like leave the Coke with. So they have to come together to form these bubbles that they can then drift out with. Do you see how this is quite similar to rain? So rain has got a similar situation where it's got loads of particles of water that are struggling to come together to form rain droplets. It's the same thing, but instead of falling downwards out of the sky, it's falling upwards out of a fizzy drink. And these bubbles are struggling to form and so that they can come out. Now, what happens when you put Mentos in is... What do people think Mentos do? And Timo's just arrived. Hi, Timo. How you doing? We are just talking about Mentos and Coke, and what happens if you put a Mento inside a bottle of Coca-Cola, and why it is that they will help it to explode very, very quickly. So Japan Mobile says they dissolve and the bubbles can form on them. Right, okay, so that's partly correct. So it's not that they dissolve, the Mentos don't dissolve, but just by some sheer coincidence of making sweets, because it could have happened with any sweet, but just by sheer coincidence, Mentos happen to have the perfect surface for collecting together exactly the right size of a bubble of CO2. So they've got bumps all over their surface that are perfectly sized so that little particles of CO2 like to collect inside them. And because they're helped to collect together by these little cups, so the particles gather together in these little cups, then they can form these bubbles that will then flow upwards. And if you put just a few Mentos into Coke, you create so many places where these bubbles can form that it just happens almost instantly. Because as I said, the CO2 doesn't want to be in there. The gas doesn't want to be in there. It wants to leave, right? But for some reason it happens slowly until you add the Mentos. What else do people think you can add to Coca-Cola in order to achieve this same effect? And Maria's just come in and said that it's just like the raisins. So let's just go back to these raisins. So raisins in fizzy water. Oh no. I've just covered my computer in water. Give me 1 second. Brief removing water break. Emergency removing water break. Okay, hopefully the computer won't die. That was bad news. Whew. Anyway, yeah, so Marie just said that it's like what the raisins did. So when you put the raisins in the fizzy water, all the bubbles will collect on the raisins and then they'll rise to the top. It's not quite as extreme as Mentos, because Mentos is like the perfect shape for it. But the raisins are quite good as well. And someone else said that you can put baking soda in. That was Maria as well. That will work too. Sand is really good. Sugar is quite good. If you want to get all the bubbles out of Coca-Cola, you just sprinkle some sugar in and they'll just whoosh, come out as well. Mia Dones said you can put mammatus clouds in. For anyone joining us late, these are mammatus clouds, which are these like sky grapes that form around the time of thunderstorms, which are really beautiful. Mammatus clouds you can't put into a bottle of Coca-Cola though, but that would be cool. Oh, Japan Maple, I'm glad to hear your laptop is fine. And yeah, salt will also work. So all you need is something that will give you a nice rough surface down on like a particle level, so that the bubbles of CO2 can get in there and all collect together to form bigger bubbles that are then big enough to then rise up and float outwards. Okay, so taking this in mind, has anyone heard this news? I say heard this news. It's actually not. It was a few years ago that this was being talked about. So researchers in the United Arab Emirates were talking about building a man-made mountain to increase rainfall. Why would they use a mountain to increase rainfall? What do people think? Gonna give some time for people to answer what they think. And also Marie says toothpaste. I'm not sure if toothpaste works in Coca-Cola. It might though. I've never tried that. And Mia Doan is saying when you look at Coca-Cola, you don't see all the bubbles. They just appear out of nowhere. That's like, as I was explaining it, it's full of CO2. There's loads of CO2 in there. It's just stuck in there. It's stuck in there and it needs to form bubbles that are big enough so that it can then float outwards. But there's something that we're about to come to where we'll explain why it's so difficult for them to form those small bubbles. And why it takes such a long time. But Mentos gives them a shortcut, so does baking powder, salt, sugar, all these kinds of things. Now, just going back to clouds. So people are saying that, so Mia says mountains have snow on them. Jasmine's saying because the rain would be like, ooh, and cluster around the mountain. Yeah, Jasmine, that's pretty good. And Izzy's spot on, saying it forces the air to rise, and so it cools and condenses. Great, so if we build a big old, how do we go over? If we build a big old mountain over to the side, near the cities, then as the air is approaching the mountain, it'll be forced to rise up. And because it's forced to rise up, it will force all of the water that's captured inside that air to cool down, and it will form clouds. So building an artificial mountain will help to form clouds because it forces the air to rise, which forces it up higher up where it's a bit colder. And where it's colder up, it'll start to form these droplets of water and it'll form clouds. And then the clouds will drift over the top like these. But why is that useful? Clouds aren't necessarily useful. Why would they just want to make clouds? What are they going to do with those clouds? Timo's saying because water evaporates from rivers and other sources to create clouds. Yes, Timo, exactly. Although often the water is just captured inside the air and you can't see the clouds. Like think about when you're in like a really humid place. You can't necessarily see the water in the air, but it's all around you. And you need to force it upwards where it's cold to make those clouds appear. And Mia said you can boil lots of kettles. Is that what to form the clouds, or to use the clouds. I couldn't figure that out. Japan Maple said, won't it mess with nature? And yet this is kind of messing with nature, which is a lot of what humans do. And so, yeah, is it safe to just change their climate suddenly? The Pumpkin Master said that's something of great debate. Like, is it safe to alter climate? Because what you do is you create a very sudden change, and sudden change in the world normally leads to a lot of living things dying off because they can't adapt. So it's always controversial to do things which create sudden change to the environment. But anyway, the proposal is to build this mountain, whether it's a good idea or not, and it will form these clouds, and then the idea is, as Izzy just said, spot on, they could use the clouds for seeding rain. So rather than using mentos, what they do is they send up an aeroplane or a helicopter or something, and from above the cloud, they drop loads and loads of powder. Now, they use a powder called silver iodide, is the normal one, and there are other powders, but it's the powder that they normally use. And silver iodide is like it's like Mentos for Coca-Cola, except it's the same thing for clouds. And this silver iodide dust helps all of these tiny droplets of water that are really struggling to come together to collect around the silver iodide and fall out of the sky. And so you can artificially make a cloud rain by sprinkling silver iodide dust through it. And this isn't science fiction. This is happening all around the world. People are doing this all the time at the moment, and there are a lot of conspiracy theories about people manipulating the weather, but I don't see why they should be conspiracy theories. Like, the weather is just being manipulated. It's happening because people are using it to control, to try and make sure it rains at the right times, to try and get rain to fall on farmland and so on. It's happening. Silver iodide sounds expensive. Silver iodide isn't too expensive, actually. It's a reasonably cheap thing to do it with, and it's very, very effective. Hey, quick aside. Now that you know that rain forms most easily around a small particle of something, like a dusty something, do you guys know what particle is one of the most common particles that snowflakes form around? And if you don't know, then you should watch the video that's on my YouTube called Disappearing Ground or Losing Ground. It's about soil, and it's got a bit in it about the really mysterious particle that's at the center of loads of snowflakes, and it's a really big surprise. Anyway, you should check it out. Right, okay, so Pumpkin Master's just taking us on a total aside, saying that in the news yesterday there was talk of how Antarctica used to be warm enough to have a rainforest on it. Antarctica used to be in a totally different place. Antarctica used to be connected with Australia and South America, and it used to be in the northern hemisphere. So yeah, like the parts of the Earth have moved around a huge amount over the history of time. Anyway, Izzy has got it spot on with the center of the snowflake. Nice. Okay, right, I'm just going to do the conclusion of all of this, which is one really, really important point which can help you with loads of understanding science. It's one really key idea of science, and that's this: that really small droplets of anything hate existing. They don't like existing. And if you want, I'll tell you in a moment why, and that gets a bit more mathsy, so I'll do that in a mo, for those who are interested. But the key idea is that small droplets hate existing. Individual particles, fine. Bigger droplets, fine. But small droplets, they do not like existing. And so if you have like individual particles of water in a cloud, fine. If you have big droplets of water in a cloud falling out as rain, fine as well. That's nice and stable. But going via this little droplet that they have to form first, when the particles just start to collect together to form the little droplets of rain, it hates doing this. It hates doing this, and that's why it helps so much to have a little something that it can form on, like a bit of silver iodide or something. And it's the same with Coca-Cola. So again, in Coca-Cola, you got all this dissolved CO2. Fine, it'll stay there for a bit. It doesn't really want to be there. It'd prefer to be out in the atmosphere. But it can also form and it's also happy if it forms these big bubbles that it can then bubble out as, but it hates forming the little bubbles, and that's why it forms so slowly. And that's why it really helps to have raisins in it. I'm going to put some more raisins in and try not to ruin my computer. Just in case anyone hasn't seen this yet. Although maybe it's not fizzy enough anymore to pull them up. Oh, that's a shame. Okay, well, if people haven't seen it before, if you put raisins in fizzy water, then the fizzy water will drag them up and then drop them back down again like a lava lamp. Because it collects together the bubbles of air and then the bubbles of CO2 and then it drags it up to the top. So yes, so if you have, if you're looking at Coca-Cola, then you've got little droplets, little bubbles, little particles of CO2, which are fine, and big bubbles are fine, but it hates forming these tiny ones, which is why it happens slowly, which is why Mentos works so well, because it throws them, it throws all the gas out very, very rapidly, and that's why Mentos explodes with Coke, just like this picture here. These guys exploding absolutely loads of it. Okay, so I'm just going to very quickly tell you about the maths, just so that people know in case they're interested. And it's to do with just the equations for the if you look at the bubbles, the equations for the surface area and the volume. So the surface area of the bubble is related to, does anyone know what it's related to? How is it related to the radius? And I'm sorry for anyone who hasn't done this kind of maths yet, we're going to move on from this in a sec, but I just wanted to do it at the end for people who want to see this bit of maths. So what is the surface area related to in terms of the radius? There's some equation there. I want to see if anyone knows. Fizzy water tastes like TV static, is what someone said before. And Jeff said, yeah, it's r squared. So the surface area is related to r squared. Brilliant. Does anyone know what the volume is related to? Timo agrees with r squared. Nice. Don't worry about the rest of the equation. I just want to know what the r bit is, because that's the important bit. Exactly. So Japan Maple's coming in with r cubed. Exactly. Brilliant. Okay. So surface area is to do with r squared. Volume is to do with r cubed. Right? Now, the surface area is to do with how much the pressure is pushing it in from the outside. So that is related to the pressure inwards, because the pressure inwards is directly onto the surface area. Now, the pressure outwards from the small droplet that's trying to form, is r cubed. R cubed is the pressure outwards, and that's holding the bubble together by holding itself outwards. Now, when you have very, very, very small r values, like smaller than 1, which one of these is bigger? The pressure inwards or the pressure outwards? So when r is very small, the pressure inwards is bigger. Very good. Japan Maple, nice. And the pressure outwards is smaller. And the other way around, when r is very big, what do people think? When the pressure is very big, the pressure outwards will be bigger and the pressure inwards will be smaller. Brilliant. Well done, everyone who got that right. And so what that means is that when r is very small, so when the bubble is very small, the pressure inwards is huge, and that throws the particle apart. It collapses it, and it throws it apart into all these little particles again. But when it gets to a big enough size, eventually the pressure outwards gets big enough that the bubble can hold itself together, and then it can survive. And that is the key idea behind, one, why why Coca-Cola bubbles come out so slowly and why you can shortcut them with Mentos by allowing them to skip that small bubble phase. And it's also the reason why it doesn't rain even though the clouds are cold, because those those particles of water just don't want to come together. So thanks very much for coming, everyone. That was really great. I'm really impressed with how everyone did on the math stuff as well. Brill. Let me know any thoughts that you have, or any ideas for other kind of topics that you want to cover. I'm doing loads of physics lately, but I'm keen to do some stuff that's like more to do with biology and nature. So like throw in ideas about that, or like send them to AimHi Live on Instagram, or there's an AimHi Lives page on Facebook as well. So check those out via our website. And thanks very much for coming along. And I'll be back on Monday at 2 again. Do tell your friends. Oh, wait. When is the next session? The next session is on Monday at 2. And Tima's asking if I still have that machine that creates water vapor. Yes, I do. And thanks, Maple. Thanks, Brown Maple. You have a good weekend too. And Mia wants plants in the environment. I agree. Yeah, okay, I'm going to plan something on that. And Jasmine wants how gravity warps time and also blood. Do you mean how gravity warps blood or just blood? I can do either. And yeah, thanks so much, guys. I shall see you on Monday. Ciao.